So these lines and the triangle that you see, these are actually consist of multiple pixels or multiple points. So I can say that if I want to draw a triangle like this, I have to first draw a lot of points, okay, in this axis. So it's becoming difficult to actually draw those points, but you get the point, right? That how we can actually, using the different points, we can draw any picture. Now, if the object is moved to a new position, it can be regarded as a new object. So we will very soon see the example, but for now just know that if the object is moved to a new position, it can be regarded as a new object. And so if the previous object was P, the new can be P prime. So let's go to the example and see what does this mean. So here, let's assume that here we have the objects. Okay, now this is actually a clearer picture here. uh, so this is our first object, which is actually, as you can see, is a set of collection of points. So this is our first object. What do we want to do? We want to move this object from this place to this one. So what we did, we moved the object, and as you can see, this is actually a little bit smaller as well. So the size also smaller. So let's assume this is one kind of transformation where you can actually zoom out, zoom in, you can change the size of the screen. So what they are referring here, if I call this object P, this one will be P prime. So this one will be a new object. Why this one will be a new object? Because the coordinate of this object and this object are different. So if, let's assume this point was 5 5. Okay, let's assume this point was 5 5 in the computer graphics system. As you can clearly see that if this point was 5 5, this point is obviously not 5 5. This one will be a different point. Same goes for all the points into the screen. So this object and this object are not same in terms of coordinate. We can call it P, we can call it P prime. So this is what they mean by a collection of or set of vertices or points, and that which can change the position of these points. So we will now see that how we can change the position of these points. So first of all, what is a 2D transformation? As you can remember that here in the definition, we have actually mentioned that an object, manipulate object in two-dimensional space, that means 2D space. So let's first see what is a 2D transformation. So first of all, the definition is 2D transformation means a change in either position, orientation, or size or shape of a graphic object. And the object can be very simple, like line, circle, arc, ellipse, rectangle, polygon. So normally whenever we are actually applying computer graphics, we actually do much more complicated operations. Okay, but to learn, first of all, to get the idea, we will only consider the simple objects. Okay, a line, a polygon, a circle. So a 2D transformation means change in either position, orientation, size, or shape of a graphics object. So whenever you want to change a graphics object, its position, its orientation, its color, its rotation, this is called 2D transformation. And why it's called 2D? Because we are doing this in a 2D space. That means we have this x-axis, sorry, this y-axis and this x-axis. So in this 2D space or in this graph, we will actually change position of graph object from one place to another. We are only considering 2D objects, that means the graph. So here all the examples that you see, as you can see in the screen, these are in the 2D. Okay, so we are changing from one position to another position. You see this one is P, this one is P prime, a larger version. So this is also 2D because it's an X and Y axis. This one and this one, this is a smaller version. You see this one is the small one and this one is the large one. So all the examples that you see in this chapter will only be 2D, that means X and Y axis. So let's see what kind of operation we will focus in this chapter. First of all, we'll focus on translation, then scaling, rotation, mirror reflection, and shear. So don't worry if you don't understand any of the name, like what does this mean. We will actually learn all these basic operations one by one. So let's get introduced with the names: translation, scaling, rotation, mirror reflection, and shear. So let's start with the translation. So as you can see from the slide, let's assume that you have an object in this position of the screen, okay, and you want to move the object to another position of the screen. Okay, so what you can do, let's just think of the drag and drop. Okay, like in your computer, what you can do, okay, if you have an icon in some place or if you have an image in some place, you can actually click that image, you can drag it from one place to another place. That means you can select the image and you can actually move that image from one place to another place in the screen. So this can be a very simple example of translation. That means the object was in one place and you actually transformed it into another place. Now here these are some official mathematical term. We'll come back to them later. Let's just now see that what happens when you actually transform an object. Okay, so I will start with a simple value, then I will come back to this. So I will be sharing a wide screen. So let's assume this is my x and y axis. So this is the y axis and this is the x-axis. Okay, so we have this graph. Now, what I'm asking you in this graph, so let's assume this is a point A. This is a point A, and I want you, so this is the coordinate of this point A is 3 and 2. So very simple, okay. What I want you to do, from this point, okay, let's assume the point is here. Where is it? Uh, sorry, the lines are not coming. Okay, let's assume this is a point A, okay, and this is the location of the point. So what I want to do, I want to move this point from this place, okay, to this place. So this is, we will start with the transformation of a single point. So what I want to do, I want to move this point A from here, I want to move it to here. So let's assume the location of this point is, let's give it a name of B, okay, and the location here is 7, 6. So this is the location. So from this point I want to move it to this point, A to B. So what changes I need to make? As you can see from the basic here, that this point A and this point B has a difference in the coordinate. So A, the value of x is 3 and the value of y is 2. In B, the value of x is 7 and the value of y is 6. So we can actually guess that if what I do, okay, if I actually add 3 plus 4 and if I add 2 plus 4, we can actually reach here. So by adding 4 with all of these two values, okay, I can reach from this point to this point. So this is a simple example of translation of one point. That means if you have a point A and if you want to transform it, translate it, sorry, not transform, translate it to point B, what you have to do, you have to add this 4 with all of these points. So this is for a single point, okay. Now let's go back to the slide. So in our slide, okay, you see we don't have a single point, we have a huge house. So we will see that from a single point how we can actually transform to a multiple complex object like a line or a triangle or a house, okay. So let's see another example first. So here, this is a point and you want to transform the point to this place. So what you can do, you can add some values with these points as I have seen in the example. Okay, now let me ask you guys a question. So let's assume, okay, now this is a point A and you want to translate this point to in this location, and the location of this point is C. Okay, and the value of C is 5, and let's assume it's 5. So my question is to you that if I want to transfer from this, translate from 32 to 55, what changes I need to make? Obviously, you can see that if I want to translate from this position to this position, in the x-axis I have to add 2, and in the y-axis I have to add 3. So very clear so far, right? So I can add a value, okay, to translate a point from one place to another place. So this can be one kind of question, that if I want to translate from one place to another place, how much we need to add. So we call it this value, this 4 here, okay, or this 2, 3 here, we can actually call it d, a distance, or t. So there are different ways you can represent it. Another question can be that, okay, let's assume I don't know this value b, let's assume this is d. So I don't know the axis of this one. Okay, your question is, if I want to move this the object here A from this position, if I want to transfer it to this position, what changes I need to make? So as you can see, previously I have exactly mentioned the point 7, 6. So you knew that from A32, if I want to translate to 7, 6, I have to add this certain amount of values. But in this one, I actually don't know, okay, what will be the value. Okay, so I have to find out that from this position, if I want to go there, what values I need to make. So basically I need to find the value of this parameter. Okay, how much I need to add or subtract. Another example, let's clear this up. So let's assume that I have okay, I have this again this x-axis and this y-axis. Okay, and I have this like this object, the combination of 3 lines. I have this combination of 3 lines, a triangle. Okay, so this is the triangle. Now, as you can see, this triangle and this triangle are not in the same size. So this is actually wrong. So let me draw it again. So let's assume this triangle and this triangle is of the same size, because we are translating. That means we are moving from one place to another place. We are not zooming or zoom out. Okay. So this is first triangle, and this is our first triangle. This is our first triangle. This is our second triangle. Now let's assume that for the first triangle we have this point, the point A. Let's assume it is 2, 1. For the first triangle we have this point, point B. Okay, the point is let's assume that 4, 1. Then we have this point, point C. Let's assume that this is actually 5 and 2. Sorry, 2 and 5. These are coordinates. Okay, and here I have another triangle, okay, whose coordinates, let's assume this is instead of, let's assume it's D. Okay, and the coordinate is 6, 1, and the coordinate of this point E is 9, 1. So if I ask you that, if I want to translate this triangle to this triangle, I can now say that instead of actually focusing on the whole triangle, what I can do, I can actually focus on these 3 points. You see, C, A, B. So if I actually drag this 3 point to a new location, okay, that means from this point, if I transform here to this point, from this point, if I transform to this point, from this point, if I transform to this point, the whole triangle will be translated. So sometimes what happens that whenever we are using translation, okay, instead of translating the whole objects, that means instead of translating the whole points here, instead of translating this all of these points, because as you can see there are many combination of these points, what we can do, we can focus on three main points, we can translate those 3 points, and in that way the whole object will be translated. Now let's go back to the slide. We have actually studied the basic term, now we have to see the bookish term. So first let's go to the definition. A translation moves all points in an object along the same straight line path to a new position. So in a same straight line path, as you can see this path is a straight line, so from one position to we can move to a new position by adding the value of x and y. So in the x-axis we will add some value or subtract some value. So if you go back to the whiteboard, you can see that here this is a 2 1, the value of x is 2, the value of y is 1. But in this one, okay, let me erase this one. Yes, so here the value of x is 2 and the value of y is 1, but here as you can see the value of x is 6 and the value of y actually should be less. Let's assume this is 0.5, so the value of y is actually decreased. Okay, so the value we can actually add, we can also subtract. So this is actually a mistake from my part. It will be less than y, the value of y will be less than this value of y. Okay, now let's go back to the slide. So, oh, okay, one point I forgot. So all of this, okay, if you actually draw a line, you will see that there is a straight line between them. From all the points, the line will be a straight line. Sorry about the lines. So all of these have a straight line between them. So that's what they're saying in the definition. A translation moves all points in an object along the same straight line to a new position. So all the points you have in an object will move to a new position, and there will be a straight difference between them. The path is represented by a vector called translation or shift vector. Now why we need vector? Okay, because you see the objects we have sometimes are actually not that simple. Like you see here we are translating a point. So the definition is if the point is 2 2 and if I translate 6 in this direction and 4 in this direction, what will be the new point? So we can easily guess that if I add 6 it will be 8, okay, and if I add 4 it will be 6. So this new point, as you all can guess, will be 8 6, right? So let me just write down the new point will be 8 6. Why 8? Because we are adding 6 in this direction x and we are adding 4 in this direction y. Okay, now here is, now sometimes what happens, the objects that we have are actually not that much simple. Like just look at this one. Okay, if I go to this object, you see this is not only one point. Here we have like a house, full house, we have a window, we have a door. So we cannot actually represent using only one point. So in that case we have to use a collection of points, and that's where the matrix comes in. So this is actually, instead of calling a matrix, we can call it a vector. So we will discuss more about this, but now let's restart the meeting. So please join again. I will be restarting the meeting.